Hello, everybody, and welcome to the Can Chats panel. Unfortunately, this had to be pre-recorded as we had some technical difficulties. I appreciate the attendees that did join. Unfortunately, we couldn't do this live. My name is Silas Jackson. I'm the moderator of this session. My background is in pharmaceuticals, and now I'm a technical sales rep for LGC Standards in environmental, food, and forensics, which cannabis falls under the food sector as it's agriculture. I'm going to start with introducing our panel. So Rob Thomas, would you mind introducing yourself?
Hey, good morning. My name is Robert Thomas, and I guess I like to call myself a subject matter expert nowadays. I've been in the field of trace element analysis for 45 years, worked 25 years for an instrument vendor in the technique of ICP mass spectrometry. I eventually took early retirement from that company, which was PerkinElmer, in the early 2000s. And I ventured into the world of science writing. I eventually published 5 textbooks. The most recent one was on heavy metals in cannabis and hemp consumer products. And that's the area that I focused on for the past 2 years. And I now call myself an educator because I was quite surprised when I came into this sector that there was no good understanding of heavy metals in cannabis consumer products, particularly in the area of cultivation, extraction, production, packaging, and delivery. So now I've spent the past 12 months trying to educate the industry about the dangers of heavy metals in cannabis and hemp consumer products.
Perfect. Thanks, Rob. Debra Kimless.
Hi, everyone. My name is Debra Kimless. I'm a physician board certified in anesthesiology, pain medicine, and lifestyle medicine. I entered the cannabis industry in 2013, where I became involved in various areas within the space, including patient care, to chief medical officer, chief science officer for cultivation and processing companies, as well as other cannabis-related companies, to developing, conducting, and then publishing research that's cannabis-based. I'm on this panel because of my interest in patient safety, as well as my experience in conducting root cause analysis investigations when heavy metals become a concern in products.
Perfect. Thank you very much. Kevin Kubachka.
Yeah, my name is Kevin Kubachka, Forensic Chemistry Center of the part of the Food and Drug Administration. I've been a chemist doing metals work for about 15 years. And FDA, although we don't regulate cannabis products, our lab in particular became involved with this problem, basically looking at metals in the vaping products. And so we've had some experience testing the e-liquids and so on related to the vaping devices. This all stemmed from the Valley crisis in 2019 with the vaping devices where people were getting sick and so on. So that's how I've become involved with this program. So.
If you don't mind, before I introduce Debby Miran, would you mind expanding on the Valley crisis? What is the Valley crisis?
Yeah, so in August, I mean, it's before COVID, so no one really remembers anymore, I feel like. But in August 2019 is basically what happens. There's a lot of reports of people getting sick, pneumonia-type symptoms, and a lot of other problems. But basically, there's about 3,000 cases. It turned out there were 68 deaths that were directly related to this, but eventually it was all tied to vaping products. And they mainly came from THC, ones from informal sources. That was a major role. Also, there's a strong link of which eventually was determined to be the cause, essentially, was the vitamin E acetate that was being used to mix with the THC in the cartridges. And although metals was not a strong link for this, it still brought up a lot of like chronic exposure effects and so on. So.
Gotcha. Thank you very much. Debby Miran.
Good morning, everyone. My name is Debby Miran. I am a consultant in the industry. I primarily consult to state regulators as far as setting up testing programs. Prior to that, I was on the Maryland Commission for 3 years. And then prior to that, I spent almost 30 years in the pharmaceutical industry as a regulatory affairs professional and chemist. Thank you.
Perfect. Thank you very much. Appreciate you all introducing yourselves. With that, we're going to start getting into the more technical aspect of this panel. So we're going to start with a question to Rob. Why test for heavy metals?
Okay, it is a great question because I think it's fair to say that there's not a good understanding of heavy metals in many cannabis consumer products, but we have to understand that cannabis and hemp Hyperaccumulators, in other words, they are often used to plant in contaminated soil, and they're used for phytoremediation purposes. So when you plant cannabis and hemp, you always have to be aware of the chemistry of the soil where you're planting it, because absolutely, if it's not planted in clean soil, there's a very good chance that you're going to absorb the heavy metals in the soil. So you have to be aware of the cultivation process. You also have to be aware of fertilizers and nutrients to enhance the growth of the cannabis plant, because there are heavy metals in fertilizers, particularly phosphate-based fertilizers, and many nutrients, and pesticides contain heavy metals. And also, even though water you assume is clean and pure, there are often cases where water can be contaminated, particularly in potable water that goes through contaminated soil. So there's the area of cultivation and growing. There's also the area of extraction. If it's in the plant, it'll be in the flower, and to some degree, it will be extracted into the flower. However, based on the extraction process, depending on what you're looking for, full spectrum, broad spectrum, or isolate, there's a very good chance based on the solvent and the pressure and temperature used that some heavy metals will be extracted into the product that you're making. And then when you eventually produce the product and you're using containers and cutting and blending equipment, which might be made of metals, particularly stainless steel, there's a good chance you can absorb those metals from the stainless steel into the product. And then when you package the product, we know that dropper bottles that are used for CBD oils, some of the low quality borosilicate glass contains transition and heavy metals. So there's a likelihood that you will absorb metals from the dropper bottles. And of course, we know that delivery devices like vaping aerosols, we know that there's a lot of products on the market which are not particularly high quality, and they contain many metal components. And if you vape at temperatures above 200 and maybe up to 400, you are going to get corrosion of the internal metallic components, and they will be transferred in the aerosol to the consumer. So there are so many points along the way of the cannabinoid manufacturing process that you have to be concerned about.
Absolutely. Thank you. Anyone else have anything to add? Nope. So we're going to go to why is heavy metals harmful for consumption? Why are we so involved and interested in this? I'll put that over to Debra Kimless.
So heavy metals, depending upon their concentration and also how the method of administration, can have a wide range of effects on the human body. Symptoms can range from something, as benign as a headache to nausea, all the way to organ failure and cancer in cases of prolonged or extreme exposure. Cannabis, because it's often combusted or inhaled, there can be an increased respiratory risk as well. But, what's interesting is, cannabis is unique because of its ability to bioaccumulate, as Rob just said, but also its method of administration different than other plants. Oftentimes it is combusted and inhaled. And so depending upon the concentration, if a heavy metal is inhaled or from smoking, it's an efficient way to get into the body, and it bypasses a lot of the other fail safes in our body, such as the liver or the digestive process. And heavy metals, once inside the body, can mimic other essential elements and actually replace them in bones or in other cellular processes. So in short, these metals can actually hijack binding sites of essential elemental metals, remove these original metals from these areas, and this can cause malfunctioning of cells and ultimately toxicity. Heavy metals, depending again on the concentration, can also create an oxidative stress, which greatly increases free radicals in the body and can cause further damage. So this is serious business.
Can I say something here?
Absolutely.
Yeah, I'd just like to emphasize that heavy metals is a very generic term, which doesn't really say much. When we talk about heavy metals in the cannabis industry, we normally associate lead, cadmium, arsenic, and mercury, which are the most toxic of the heavy metals. But there are a whole group of other elements which are heavy in nature, but not classic heavy metals. And these metals also can be problematic. And I've done a lot of work looking at an expanded panel of heavy metals or elemental contaminants, I like to call them. And I'm trying to convince the industry that they should not throw away the term heavy metals, but treat it with caution, because there are many other elemental contaminants which are potentially dangerous, which can get into the cannabis and then can be consumed by the consumer. So I just think that we have to be aware that heavy metals is a very loose term. And the work that I've done suggests that maybe up to 15 elemental contaminants should be worthy of consideration when we're looking at cannabis and what elements that we measure.
Yeah, absolutely. Yep,
Can
go
I
ahead.
say?
Absolutely.
I agree with Rob for sure. For example, chromium, when inhaled, can be highly toxic and a lung carcinogen. But we have to understand it depends upon the valence of that chromium. So chromium 6 is highly toxic to the lung and is attributable to lung cancer. Chromium 3 is an essential element. Again, concentration matters. And so I think we need, before we expand a panel, is to make sure that we can assay what we think we're assaying and make sure that what we're considering as safe or dangerous to be quantified. And as of right now, chromium, for example, cannot be parsed out in its valence. And that the states, which is Maryland and New York, that is assaying for chromium does not distinguish a difference between 3 or 6. So I think that's, something that can be considered of as well.
Absolutely.
Yeah, and I think, okay, just to add to that, is that chromium 6 is man-made. Hexavalent chromium does not occur naturally. It's man-made by industrial processes. But chromium 3 does occur naturally. So no state at the moment specifies any oxidation state for the element. So the question is, total chromium is important, but it's not in the panel of the majority of states in the US. But if you're going to monitor chromium, it's absolutely critical that you understand, is it hexavalent chromium or is it trivalent chromium? And the industry is so far away from carrying out speciate analysis, not only on chromium, but arsenic, mercury. There are many, many other elements which are toxic in certain oxidation states. So I think that we have to educate the industry that it is important when we monitor a heavy or an elemental contaminant that we fully understand in what oxidation state that metal exists.
Absolutely.
Yes.
Perfect. And I guess this will go over to Debby Miran as, as a regulator, how do you take all of this information in and kind of formulate, and prove why heavy metals are so important to the industry? Why is it so important for us to test for them and whatnot?
Well, and thank you for the question, just by way of a little history. This all came out of the 2014 AHP monograph, where editor Roy Upton suggested some tests, and this was at the beginning, really, of the concept of even testing at all for anything. And so in his monograph, he suggested, as we call them, the Big Four. This was never meant to be a regulator's guide, but it quickly became one because the states lacked any sort of direction. And so Washington State was the first to pick this up. And I can tell you, as states followed, we weren't necessarily thinking originally, we were just following. And so it suddenly became, the Big Four suddenly became what every state was going to be doing. Really, Maryland broke the mold when we started out with the Big Four, and then we added 4 more. The current commission now has since backed down to 5, keeping chromium, as Deb Kimless had suggested. So I think that if I'm thinking like an FDA regulator, FDA tends to, and no offense, Kevin, to be more reactive than proactive. And so the EVALI crisis is a perfect example of that. We didn't think about necessarily the quality of the vaping devices that were being imported into this country to be used, whether it was for vaping tobacco products or cannabis products. So I think the states tend to follow that pattern somewhat. So we will probably see more reactivity than proactivity.
Yeah, okay, let me just add to that. I think it's fair to say that guidance for the cannabis industry is coming predominantly from the pharmaceutical industry. And when the pharmaceutical industry decided to regulate elemental impurities in drug products back in the mid to late 90s, it took them 20 years to come out with comprehensive regulations. But they put forward a risk assessment strategy to understand the toxicity of the heavy metals, but not only that, but to know the likelihood of where they might occur in the pharmaceutical manufacturing process. So they eventually ended up with 24 elemental impurities based on their toxicity impact, and they're classified into many, many different classes, which was based on their toxicity. So the pharmaceutical industry has a model that the cannabis industry could follow, but the cannabis industry needs to think about doing a risk assessment study on the toxicity impact and the elements that are likely going to be occurring in the entire manufacturing process, and they're not there at the moment.
Agree. And the method of administration, because cannabis different
Yes,
than the other,
absolutely.
plant
Absolutely.
is unique in that, the method of administration actually matters and varies tremendously depending upon what the patient chooses.
And also let me add, just from a practical point of view, states really aren't equipped to do this work. Independent testing labs certainly are not going to do this work. And so we've got to figure out who's going to do the work. There are national organizations like AOAC and ASTM and NIST, but it's going to have to be a very deliberate effort. And maybe Kevin, you can speak to that, because I think that if we're waiting for this risk analysis to be done by the states or by the private sector, it's not going to happen.
I can't really speak to any FDA regulation. I know from experience that we've gotten calls from labs. I'm sure Rob has done the same thing, where labs from across either contract labs or state labs to say, hey, we're not sure how to test this. What kind of methods do you have? So it is progressing. I know AOAC does have they're starting to come out with some methods that are general metal testing, and that they do go the big four plus a few other elements. So that stuff is progressing. I know ASTM is also doing the same type of work, is to try to get some methods out there for people to use. So I think it's definitely progressing. It seems to be a lot more, at least from the people that have contacted me or people that I work with in these areas. It's getting better, but like they said, it's still in its infancy as far as how many people are testing, what they're testing for, what methods are they using, and then are they doing the right QC? So that's the kind of stuff that you're going to run into.
Yeah. Okay. Let me just add to that. I think, I think we have to get a perspective of a company that has actually has an approved CBD-based drug in the U.S. and it's for childhood epilepsy, and it's a company called GW Pharmaceuticals that went through the process 5 or 6 years ago of getting Epidiolex, regulated in the U.S. And what they did was they had to show compliance by showing maximum limits for class 1, class 2A, and class 3 elements of the ICH Q3D panel. And that's 14 elements in total. Those 14 elements are approximately the same as the entire list of regulated elements by the entire state. So I think that there's a good understanding of what the FDA might want to look for when eventually they can scrutinize the industry. And that's the 14 elements specified in class 1, class 2A, and class 3 elements specified by ICH and USP chapter 232.
Yep. And kind of going off that, so I know right now cannabis in the US is federally still illegal, right? So what do we recommend to the labs to kind of do to make sure that they're efficiently testing for the right amount of heavy metals or elements?
Well, let me take a stab at that. And I was going to say this earlier, so let me just lead with this. One thing to remember too, and I'm not sounding like a regulator, but we can't price product based on all these tests to the extent that patients, especially patients, but consumers as well, are just going to say, forget it. And, the black market remains alive and well. And that's really where I think we've seen the most dangers. I mean, Kevin spoke to that when he talked about, 2019. So I really think that, Rob, I guess you're going to disagree, but I really think right now, I'm happy with the big five. I think that we're covering it. We have not had necessarily reports from any of the state programs about people falling ill. We have had reports of products that have been tested that have been over the limits. You know, that's a manufacturing, processing, cultivation issue, not a testing issue. So, I mean, you can't rely on the testing for product quality, and we all know that. It's built into the process, starting with the cultivation and the growing of the plant.
Well, Debbie, yeah, I agree that the big five is better than the big four. But I think it's fair to say that if you're going to monitor chromium, or whether it's speciated or total chromium, you also have to think about monitoring elements which are similar in nature to chromium, elements like nickel and vanadium, which are class 2A elements in pharma. And those have to be monitored. Every pharmaceutical product has to monitor those elements, including lead, cadmium, arsenic, and mercury, for oral drugs. And if the drug is going to be inhaled, and many cannabis products you're getting inhaled nowadays, you also have to monitor class 3 elements. So even though I'm saying the big five is better than the big four, many of the states just have the big four. And I really think that we have to consider, particularly as many cannabis products are inhaled nowadays, that we also have to think of an expanded panel. And I'm just trying to get the industry to look at an expanded panel and look at the ones which are worthy of consideration, and maybe do a little work to find out, especially as hemp is grown outdoors nowadays, there are elements which you would never ever think would be in a cannabis and hemp product, like uranium. If you plant hemp in a soil which contains uranium, it will be sucked up by the plant and end up in the flower. And I think we always have to keep an open mind about what are the potential source of elements in a product that's predominantly grown outdoors, as in the case of hemp.
So I agree. The challenge, though, as Deb Miran said, is that we've got to balance, testing real world evidence, are people getting sick or not, versus the price. Because if we outprice, because this heavy metal testing is very expensive, if we outprice these products, patients are going to go, back to the illicit market, and the whole Avali thing, will happen all over again, without us having the ability to save people from what they don't know. A lot of people think, a lot of patients that I speak with say, hey, why can't I, if cannabis is safe and it's legal in X number of states now as a medical therapeutic agent, why can't I just buy it off the street from some person, and they don't recognize about the testing? There's a huge disconnect in patients, and even in people who use it for adult use or buy CBD from their gas station. There's a huge disconnect, thinking, oh, it's legal or it's not illicit anymore, or there are many states. They don't get that, these types of testing is for their safety, and therefore not willing to pay for it. So, and on top of it, there's no, as Deb Miran said, there's no overlaying uniformity in testing. So what you go to one state is completely different than another state. And what you fail for in one state, you pass for in another state. So there's really has to be, on the federal level, unification of testing methodology and a way to make these prices reasonable, so that patients don't end up being forced into an illicit market.
Yeah, but are you okay? So let me push back a little bit there. Are you talking about the cost of testing? Is that what you're talking about?
The cost of ultimately so heavy metals is just one of many tests that this product is subject to prior to release in a state controlled market. And all of these add up ultimately to the end user who ends up paying for it.
No, I agree. Testing, it does cost, it is relatively expensive, but I think it's fair to say that the technique of ICP-MS can measure the periodic table in 2 minutes. The testing of, say, 15 or 16 heavy metals is insignificant compared to testing 4. So I don't think the cost of testing for an additional panel of heavy metals is going to make a significant difference. In fact, I just published some work in Analytical Cannabis, showed that it cost about 35 cents a sample to test for 4 elements, and it costs 52 cents to test that same sample for 15 elements. So the cost of the increased cost of testing for 15 elemental contaminants is trivial. So I don't see that being an issue. And I just think that that is something which is important to emphasize, that I've talked to many testing labs and they've talked about the increased cost of testing for heavy metals. But, you know, my point is testing for heavy metals will cost no more for 15 as opposed to 4.
So that may be true, but in the real world of cannabis testing, we get handed a very large bill for increased, anything, and maybe it's to amortize their equipment. So maybe the reagents are not expensive, but I can assure you that these are very expensive tests. Deb Miran, do you want to, since you're involved in laboratories, do you have any comments on this?
I don't, but one thought I had, and I thought of this earlier, and that is, not every element necessarily might have to be a QC test of every batch or every lot. Sometimes in the pharmaceutical world, which I came from, you can do research and you can study this and you can look at X number of batches over time and say, we have never seen uranium. We have never seen this heavy metal. And so you've established that. And as long as you don't change your process significantly, you're reasonably assured that the ones that you need to monitor as a QC function, batch to batch, lot to lot, can be minimized. I love your thoughts on that, Rob.
Yeah, no, I agree with you, Debbie. I think it's fair to say that you're not going to find uranium in all soil in the US, but certainly if you're planting hemp or cannabis near, say, an old DOD or a DOE site, or maybe a uranium mine out west, absolutely guarantee there will be uranium in the soil, and your likelihood will absorb it into the plant and into the flower. But that's not going to occur everywhere in the US. But look, I mean, NIST just came out with a hemp, or will be coming out with a hemp certified reference material in the next few months. It contains a 13 elemental panel, including uranium. So, and it's there. If you look at the data that NIST have, presented, there is not high levels of uranium, but there are levels of uranium which could be of concern, and it will be in the hemp certified reference material. So I just think that we have to be aware that there's data out there, there's information out there that people are carrying out the testing procedures and finding these obscure elements in some hemp and cannabis products. Yeah.
Yeah, definitely take geographical location into consideration, and should definitely factor into the tests that each of these locations are actually testing for. Kevin, I'm not sure if you can actually attest to this based on any of the research that you've done. The need to expand, have you seen the additional analytes in any of the research that you guys have run in the FDA?
I think it depends on what you look at. We have a paper coming out pretty soon from the Native Valley crisis, and essentially it's stuff that was pretty well known as far as vaping. I mean, it was a lot. Nicotine work has pretty much shown that before, that you get some stuff coming from the cartridges. So that's kind of stuff we had. I mean, it was stuff that was expanded. I mean, like Rob mentioned, chromium is a possibility. We just see some. I think there's some chromium. I mean, other things that people mentioned for nicotine. Zinc, copper. Nickel is another one that are pretty high that come from some of these cartridges, especially some that are from informal sources. So, I mean, just because it's there and present, I mean, there's not been enough studies that say, like, I think there's some that are coming out now that's like, well, it's in a vaping device, what actually makes it to the aerosol. So some of that work needs to be done. Mm-hmm. There's still, I think the main thing is, yeah, maybe there will be more elements to do, but I think like Rob and everybody here said is it's going to take more work, to be honest, because you can sit there and say, yes, this might be a good case for this element, but is it realistic? Is it going to be there all the time? And does it matter? So I think it is a balance between that. But I mean, for sure, you can test for all these and then, and see what you see basically. But I think that's the main thing.
Yeah, and I think, okay, just to add to that, I think vaping devices are rather unique for the cannabis industry because there could be no lead, cadmium, arsenic, or mercury in your cannabinoid or in your diluent oil. But when you ramp the temperature up to maybe 300 or 400 degrees Celsius, whatever's in the vaping device will absolutely be transferred in the aerosol to the consumer. And we know that you can test a vaping cartridge for the liquid, and maybe you will have elements which are below state-based limits for lead, cadmium, arsenic, and mercury. You ramp the temperature up to much higher than 200 or 300 degrees Celsius, and guaranteed there's going to be some kind of corrosion taking place. And the question is, how do you trap and collect that aerosol? Because you're not looking at the liquid in the tank, you're looking at the aerosol that's being transferred to the consumer. And I think there's a limited amount of research out there at the moment, but the folks at the CDC have just published a paper on this, and some of the testing labs have also done some work that alloys like like nichrome or cantonal, stainless steel, these are used in many vaping devices, and these metallic components are corroding and finding their way to the consumer. And some research has shown that it's in particulate form. So it's not in ionic form, it's not in solution, it's being transferred in the aerosol in the particulate form. So when you start taking particulate form of chromium, nickel, iron maybe into your lungs, that's a serious area of concern. But that, those are elements which are not typically regulated by the states because they're not found in the cannabinoid or in the cannabis, but they're a direct result of the vaping mechanism.
So let me add to that. And this would come from what FDA would expect if they were in charge of the universe. When you've got a drug device combination, the device needs to be studied and QC'd and monitored just like the drug does. And so I would say as a regulator that you put that burden on the device manufacturer. And so what the states then would do is to set up specifications for the device as a component. And those would have to be met. And the burden should once again be on the manufacturer, not on the cannabis processor or cultivator. And so that way you can keep some of the substandard and potentially dangerous devices that might be coming from other countries that maybe have different standards to produce and different materials that they are allowed to use to manufacture them, keeping them away from patients and consumers. New York, I believe, is the first state that I've seen that has actually drafted some rules to say we've got to put some specifications around these devices, and I think that's a good trend. I would support that.
Yeah, and I think it's fair to say that many of the vaping devices are coming in from overseas, and they're coming in the millions, and they're not high quality, and they're finding their way into the marketplace, either as pre-filled devices or devices that you can fill. But there's no question in my mind that there can be better materials that you can use for vaping devices, more corrosion resistant material, maybe ceramic, maybe more corrosion resistant metals. But these devices are low quality, and they're clearly being brought in for price. And I think there would be resistance by the industry because, jokingly, I said to one manufacturer, maybe you could gold coat all the metallic components in your device. I was being serious in a cynical sort of way, but it requires that sort of thought behind these vaping devices, even to eliminate metal completely from a vaping device and maybe use ceramic or maybe use polymer in nature. But I think there has to be a rethink about the materials that are used for these devices.
Would we not be concerned about the significant cost barrier to entry that would kind of trickle down to the consumer in those cases, though?
What I would like to say to that very simply is the cost of one recall, just one,
True.
isn't for you to want to use higher quality materials so that you never would have to go through that.
And I think patient education surrounding this would be positive. People would understand that this was a, hopefully a one-shot purchase, and then perhaps it's refillable. So, it's a singular cost, and then they're able to, reuse the device. But I agree with, what Debbie's saying, with the device really should be looked at as stringently, if not more so, than, the cannabis and the process and procedures surrounding that.
Absolutely. I mean, look, the E-Valley crisis hit us. It was totally unexpected, but all of a sudden, within months, 3,000 people were hospitalized and almost 70 people died. There is the potential for something like that happening again. I'm not wishing it, but I believe that unless something happens and we take some action into minimizing or reducing the likelihood of toxic heavy metals being transported into someone's lungs. And, vaping is the desired delivery method for many, many cannabis consumers. I was talking to someone recently who suffers from adult epilepsy, and he has for all his life. And he's found a cannabinoid product which he delivers by vaping, which really eliminates just about all of his seizures. He's totally amazed by how effective it is, but he's concerned about these metallic components in these vaping devices. So he's worried that he could be delivering another toxic component to his lungs, even though he had solved his, or he had reduced his, bouts of epilepsy. So
going off that, what would be with the components that we currently have to use as a community, what can manufacturers do to kind of minimize the heavy metal contamination that are that's undergoing in the contraptions that we use? Anyone?
Yeah, let me take a stab at this. Okay, you're talking about the delivery devices in particular?
Yep.
Okay, well, look, there are other methods of delivering cannabis, obviously. Vaping is just one of them. But even if you're talking about using some form of tincture or some form of oil, whether it's, delivered orally, we really have to look very seriously at the equipment that's used to contain and store these products. I was staggered. I actually chaired a heavy metal in cannabis workshop, a 3-day workshop for the ASTM back in June. And there are a number of presentations which showed that simple things like dropper bottles, you can measure, you can monitor the heavy metals in the cannabinoid oil when it's first put into the dropper bottle. But if you monitor those heavy metals over weeks and over months, what's happening is that it's extracting or absorbing heavy metals from the bottle. And being an analytical chemist that has worked in the field of trace element analysis for so long, you know what equipment and you know what components and what products that can be used to carry out ultratrace analysis. And you would never ever use borosilicate glass. It's the dirtiest material out there, and you cannot use it when you're doing ultratrace element analysis using ICP-MS. So the point I'm making is that the industry is using materials and using equipment which is not really suited for storage. And these researchers down in Florida were showing that the heavy metals, particularly lead, they were initially below state-based limits, which was 0.5 ppm lead, and over a period of time, they were increasing to 10 times above the state-based limits to 5 ppm. So the point I'm making is that it's not only vaping devices, but it's the containers and the storage devices that are used by the industry. There needs to be a lot more thought going into how you store this material.
And once again, I'll say that this is product development. This is research. This is something, once again, if the FDA were involved, you have to show that you have no interaction between the container and closure system and the product. And it's especially intimate contact when you have a liquid. And so you would be, during your development phase, picking the container closure system that you chose, and you'd be doing accelerated stability studies to exaggerate these conditions to see if anything leaches out or there's any kind of interaction whatsoever. This industry, this cannabis industry, is not doing that right now. And they will not do that unless they are forced to do it. So I think that we're going to have to just have a culture shift. It will happen. We've seen changes that have happened since, the last 7-8 years in the whole testing arena. And so that level of sophistication will come when it's required by the regulatory bodies, whether it be the states or the federal government.
So I
Yeah,
agree with both of you. I mean, but we have to look at all the inputs and touch points or contact points where the cannabis plant is exposed or it's extracted, and methods of extraction. So grow media, fertilizer, amendments, supplements. I mean, all this stuff seems pretty obvious. But even during like the harvest and trimming and curing techniques, anywhere where cannabis is, makes contact, something as innocent as stainless steel scissors can lead to leaching of a metal into the cannabis product that would lead to a problem. And to storage containers, to what Rob said, I mean, all of these things need to be addressed. And Deb's right, the industry is just not there because this industry grew from an illicit market that suddenly from a rear view mirror said, oh, by the way, we should regulate this now. And so the regulations and the testing and the aha moments of, oh my God, this stuff may not be good for us is sort of catching up.
Mm-hmm.
And because still in this country, at least, we don't have a federal body overseeing all of this, is creating interesting conversation for us today, but some challenges within the industry.
I look, I mean, this is something that I've looked at in great detail. And in fact, I'm putting together a publication on this, but the pharmaceutical industry went through an exhaustive root cause analysis system to find out exactly where the touch points were. They looked at manufacturing, they looked at the water, they looked at the excipients, the fillers, the additives, the APIs. They looked at every touch point of the entire pharmaceutical manufacturing process and came out with this exhaustive study which said this is where you should be looking and this is where the likelihood of finding certain heavy metals. And they looked at the toxicity impact of these heavy metals. And I'm trying to convince the industry, quote unquote, that this is something that you should consider. But Deb and Debbie, you're both right. The industry won't do it unless they're forced to do it. The pharmaceutical industry was forced to do it. I remember in 1995, when the pharmaceutical industry were mandated to change from one heavy metal, lead, by a colorimetric precipitation method to monitor 24 elemental impurities. They were kicking and screaming for a couple of decades, but I'm telling you, once they got there in January of 2018, they realized that it wasn't that bad. And every pharmaceutical manufacturer now has to show the FDA that you are fully conversant with your touch points, where they could possibly be, and you have to show evidence to the FDA that those touch points are not potential areas of concern. And that's something that I've working with the pharmaceutical industry as being the ACS heavy metals expert, work very closely with aligning ACS testing methods with USP testing methods. I was intimately involved with that process. So when I came into the industry 2 years ago, I knew this root cause analysis and this risk assessment way of approaching heavy metals or elemental contaminants was absolutely critical that the industry got to grips with that. And it's a struggle and sometimes it's frustrating, but I'm convinced that it's slowly going that way. And as I say, I'm working on a publication, which I'm hoping to co-author with USP folks who I know very well. So to give it extra credibility, I'd like the USP to co-author that with me. So it convinced the industry there's some credibility behind this information.
Perfect. So then going off that, we've talked a little bit about low trace elemental analysis. It's going to be a twofold question. One would be, how can we test for heavy metals in the industry? And then two would be, what is the best way and most reliable way to test for heavy metals in the industry?
Sure.
Kevin,
I
go
don't know.
ahead.
I can take a quick guess at this. I mean, obviously, I think we've said this a couple of times. Is ICP-MS has to be done. I mean, especially with the limits that are proposed by the states, you can't really get there with graphite furnace or optical or whatever. And for solid materials, you basically have to do some type of microwave digestion. Hot plates and stuff like that aren't going to cut it. So that's kind of the methods that are out there, at least through AOAC and ASTM. That's kind of what involved. But the big thing we've ran into is just contamination control, keeping things clean. Like some of these labs aren't set up to do metals. I mean, it's different than doing pesticides. You don't have pesticides floating around your lab unless you're a pesticide lab. Like you have metals in your lab no matter where you're at, and controlling the blanks and stuff like that is also an issue.
Perfect. Anyone have any? Go ahead.
Yeah, Kevin, that's actually a great point. I think it's fair to say the cannabis testing labs really, I mean, some are pretty good, but others don't have the expertise and have not worked in the ultra trace element environment. So you can't put an ICP-MS in a warehouse and expect to get good data. But the whole process from taking in the sample, grinding it up to a convenient form that can be placed into a microwave digestion equipment, and then being digested where there's nothing floating around, there's no particulates, that it's totally in solution, and then diluting that sample into a convenient vessel which is made of a material which does not have any kind of contamination, and then transferring that to your ICP-MS and analyzing it with good accuracy and precision, and to be able to validate your data, to be able to implement a validation procedure or validation protocols which says that you can absolutely guarantee the result that's coming out the end of the instrument is correct within the limitations of your procedure. And unfortunately, labs typically do not have good validation protocols. The pharmaceutical industry went through this 20 years ago when there were no pharmaceutical materials which were considered certified or standard reference materials. So they had to implement a comprehensive spiking procedures to make sure that they spiked all their samples pre-digestion to make sure that you're not losing any elements, because it's quite easy to lose heavy elements by microwave digestion, particularly elements like mercury, which are known to be very volatile and stick to the sides of vessels. And spike your sample and be able to recover those spikes at the end of the analysis to make sure that analysis is validated. And cannabis testing labs in general are not going through that procedure. And let me emphasize again that pharmaceutical industry is mandated to carry out 24 elemental impurities based on the delivery method, oral, parenteral, inhalation, or transdermal. And when the FDA inspects a pharmaceutical manufacturing plant, they will look at their validation protocols. And there's an exhaustive set of validation protocols pharmaceutical manufacturers must go through and show the FDA that the results they're generating are accurate and precise. And the cannabis industry does not have that scrutiny at the moment. And I can tell you not all testing labs, but many testing labs are not going through that validation protocol. And until the National Institute of Standards and Technology comes out with a hemp or a cannabis certified reference material, which they will do next year sometime, I don't think we can be absolutely convinced that many testing labs are generating good data.
So let me jump in here a second. We are seeing a good trend, and I am going to give a compliment now to a few states, but we know that there's a void in validation, not just for heavy metals tests, but other contaminants such as pesticides, et cetera. States are now having some money in their state programs, which means that they can spend it. And there is a trend beginning now, and has been for some time, that states are setting up and funding their own testing labs. So they've got their own facility, their own equipment and staff. California is about ready to launch their state lab, hopefully opening their doors the 1st of December. Maryland is actively looking for space to do the same thing. And on top of the list of priorities, at least in California, I've been working with them, is to look in depth at methods validation for all the testing methods that are being required. And so once again, this is the work that the private sector really cannot do just by virtue of time and their business models. And so I think that we will see these states. New York is going to be jumping in. Connecticut, we're going to see them starting to do some of this work and maybe providing the data that, Rob is suggesting that we need. The other thing we just don't want to see happen, and this happened in Massachusetts, is to arbitrarily set limits that the levels of detection of the instrument cannot achieve. Massachusetts went through this, especially with pesticides, and it was a disaster because they had set limits that were just so ridiculously low that nothing was passing. So states have to be mindful of that as well.
Perfect. Just want to let everybody know we are running a little low on time. So next couple questions, try and keep it a little bit briefer. Going off what you had just said, Debbie, are there any concerns about either false negatives or false positives that we've seen in the industry?
We're always concerned with that. And that gets back to validation.
Okay.
Simple, short answer.
And then, what seems to happen if heavy metals do exceed the permitted values that states have regulated or set in stone?
Deb, do you want to answer that as far as remediation?
So that's a challenge. So there are many states allow for remediation. Some states do not permit remediation, but remediation of heavy metals is a challenge. I mean, it's not an easy solution as compared with a micro remediation or a moisture content remediation. So many states do allow, but getting to that is challenging and expensive.
Yeah, I was going to say it's extremely expensive. I was talking to a cultivator in Colorado, and they had a whole bunch of hemp which need to be remediated, and it was horrendous what they were telling me what it was going to cost them. So yeah, I mean, I think obviously don't have it in the flower to remediate, because it's going to cost you a lot of money to to remove it.
Mm-hmm.
But I also think it's fair to say that many cannabis consumer products are hitting the marketplace and they are over the regulated limit for the states. I make a point of looking in the public domain for all product recalls or anything that can have an iota of a product recall or is above the limit, or there's a dubious certificate of analysis, there's a confusing certificate of analysis, or it's just over the state-based limit. And I've counted 20 in the past couple of years, which have either been recalled by the FDA or the state regulatory system has slapped the wrists of the manufacturer. So they are getting out into the public domain, they are getting out into the marketplace. But I'm not too sure there's any serious repercussions when a producer is selling a product which is clearly above the heavy metals limits for that product. And I don't know the process well enough in the cannabis industry. I know in the pharmaceutical industry there would be serious repercussions to the manufacturer if they put out a product which is above the PDE limits for that delivery device, but I'm not too sure how the cannabis industry approaches that.
In many states, they're not even allowed to release it. So they will not get their certificate of analysis in order to release it to the public for purchase. So what happens is the producer ends up, swallowing it until they figure out how to remediate it or just trash it. So.
Oh yeah, okay. The point I'm making, there doesn't seem to be any way to track back through the system where that occurred. Okay, that's the point I'm making. That you have a CBD oil which is 5 ppm lead and it should be 0.5 ppm. Where did the system break down? I don't understand the cannabis industry's way of tracking that back to where it broke down.
So that's independent, depending upon the manufacturer of that particular iteration that you're describing as an example. Yeah. So they would have to conduct their own root cause analysis and look at all the inputs, which is why I'm suggesting to do that input analysis before you invest in a 100-day cultivation process and then additional curing and drying and then testing. For sure. And I think a lot of the manufacturers and producers have learned the hard way that those things are really important and, were not a consideration when they applied for application for the different states to become this producer. So, as Debbie said, the industry is sort of growing up around all of these issues as opposed to trying to solve for these problems before they happen.
Right. Yeah.
Perfect. So with that, I'm going to wrap it up, give everybody a chance to say a final comment, and then, we'll end the stream. So Kevin, anything to add?
No, I don't. I think the only thing I would say is just the main thing is looking at data, trying to get as much data as out there. I think the better, and then develop labs to develop methods and try to be somewhat uniform in doing so that the data is more reliable, basically.
Perfect. Rob, final comments, concerns?
Yeah. Yeah. Look, I've spent a couple of years in this industry trying to understand heavy metals and where the contamination sources are, and I'm encouraged by the way it's gone over the past 2 years, but it's still very frustrating, I must admit. I think I'm getting some momentum, and I feel that the more people that are talking about heavy metals, the cleaner the industry will become. Because I think it's important to emphasize that these are medicinal products, and we're giving these products to people with compromised immune systems. And I think we always have to be aware of that.
Perfect. Deb Kimless?
So I agree with Kevin. I think that standards need to be metered for all states. And I am actually pretty optimistic as well that at least we're having these types of conversations, not only about heavy metals, but about all the potential contaminants within the cannabis industry and how to measure them and how to make those measurements uniform so that patients and physicians can feel okay about making these recommendations and using these products.
Perfect. Debby Miran?
And what I always like to say is I do work in states. I have this goal of making every state program better than the one that I just worked on. And so if we keep that attitude and with that kind of a culture, I think we will get to where we want to go.
Perfect.
Thank you.
I appreciate all of you for all of your amazing information that you provided today. To anybody that's watching this, if you have any additional questions, please feel free to reach out to us. We're more than happy to assist. And with that, we can conclude this. Everybody, thanks again. And we'll all talk soon.
Thank you.
Bye-bye. Thank you.
Bye now.
Thank you very much.